Number one is centripetal force equals the friction force. This is one of the example problems that we're going to look at, and it's always on every test. It's pretty representative of centripetal force in your everyday life. Whenever you go around a corner, your centripetal force has to be equal to your friction force. Friction is causing your centripetal force. If the friction is not great enough, then you'll go flying off and you'll crash into something. But you won't stay in the circle for sure. So I've got some information from TBC go-karts, and here it is. So from TBC go-karts, I had to get some information from them and then look back at a previous field trip that we had, because we didn't have the accelerometer on someone this time. I couldn't even get the radar gun out there because we had a little bit of a lunch issue, and I couldn't get back on time to get someone to wear the vest and do the radar gunning. So we used the data from a previous group, and here it is. The speed was equal to 30 kilometers per hour, or very close to it, as they went around the curve, okay? It was a little bit more, it was about 31 or so as they entered the curve, and as they came out it was about 29. So it was very close to 30 on average as they went around. And the radius of the curve was 4.2 meters. This is the last curve. I think it was called curve 8. So if I was to draw this thing, it would look like this. That curve went like this, and the radius of the curve was right here. That's where the car was. That radius was equal to 4.2 meters. And that car traced out a radius in a circular path of 4.2 meters, okay? And I radar gunned here, and both times, and actually all the way through, it was very close on average to 30 kilometers per hour. Okay, we have to change 30 kilometers per hour to meters per second. So if you don't remember, here it is, the conversion factor. Divide by 3.6, and you'll get meters per second. So could you guys just let me know what that is in meters per second, please? What do you guys get? 8. Nice. Thank you. And that's meters per second. So the question would be, or could be, if this go-kart just began to drift, in the corner above, this corner right here, then the friction force is equal to the centripetal force. It's just equal to. Ideally, your friction force would be greater than the centripetal force so that you got enough friction to make that curve. But if they just start to drift, if they just start to slip, then the force of friction equals the centripetal force. And my question would be, what is the coefficient of friction between the tires and the track? And it may look like you got a whole bunch of gibberish up here, but it's going to make sense in a minute. If it just starts to slide, my centripetal force just equals the friction force. So F cent is equal to force of friction. If you guys remember from last year, and even earlier this year, force of friction is mu, that's what we're looking for, times the normal force. And if you remember from last day, 2 days ago, we talked about F centripetal being mv squared over r. So we got mv squared r is equal to mu times F normal. Doesn't really tell me a whole lot yet, but it will. This car is sitting on a track. It doesn't have anyone pushing it down or lifting it up. It doesn't have fins on it to lift it up or push it down. And it doesn't have too much aerodynamics to actually lift it off the track. And it's a level track. You guys were on it. It was flat. So you could just say F normal is equal to the weight. So mv squared over r is equal to mu times the weight, just like last year. F normal usually equals the weight. And remember, weight is mass times gravity. Gravity being 9.8 on Earth. This is mv squared over r. I'm still looking for mu. So this is the number I'm looking for right here. Look at the m's. It doesn't matter what the mass of the person was in the car, or even the mass of the car. It's the same here as it is here. So it's irrelevant. I'm looking for mu. And so what I'll do is bring just the mu over to one side, and then all the other stuff to the other. So this 9.8, I don't want it here. So I divide this whole side by 9.8, divide this whole side by 9.8. And I've got this number, and I've got this number. So I can find out what the coefficient of friction is. I'm curious about it. So let's find out what it was for this person. We've got the speed in meters per second. It's 8.33 squared. We got the radius. It was 4.2. And this is 9.8. What is that coefficient of friction? What do you guys get? So just crank it out. Anyone with an answer yet?
About 1.686, rounded up.
Okay, 1.6. So we got a very sticky corner. Remember, the higher the coefficient of friction, the greater the friction will be. So this is quite a sticky corner. If we had another corner, for instance, that had a lot of dust on it, then this is probably drop off to 1.2. They can't make that corner at the same speed. It wouldn't have the same coefficient of friction. They would end up sliding off. This corner that we had right here really was well cleaned though. And the tires were quite warm by the time they got around there. I took this particular reading towards the end of the race. So all the tires were warm. Last time we went was towards the end of the year. It was in May actually. So it was warmer concrete temperature, warmer tire temperature too. I don't think you guys had 1.68. I'd be surprised if it was much more than 1 on your particular day that you were there. I know you weren't going the same speeds that those other guys were going as you went around those corners because you couldn't make it. But given the information we got right here, that's what we got. Okay, that's part A. The second part is this. And I'm just going to do this part right here. What was, so this is part B, your centripetal acceleration. If we're talking about this problem right here, okay, so this is B. So if that was you driving, what was your centripetal acceleration? And how many G's were you pushing as you went around this corner? So you just go centripetal acceleration is equal to V squared over R, which equals 8.33 squared over R, which was 4.2. What is that? What do you get? It's a pretty big number. Oh, sorry. 16.5. Anyone else too?
Yeah.
Nice. Okay, so 16.5 meters per second squared. And how many G's is that? Do you guys know about approximately? Anybody? Just wing it.
A little under 2.
Yeah, a little under 2, exactly. Because 1 G on Earth is equal to 9.8 meters per second squared. So just divide this thing, 16.5 by 9.8, what do you guys get? Nice. That's a lot of G's. You guys, if you're holding on to that bar and you're really making curves like that, no wonder your arms were sore by the end of it. Because you really had to hold that wheel in and hold yourself up against pushing into the side of the car with 1.68 times your body weight. Just say you couldn't make this curve and you were only feeling about maybe one coefficient of friction of 1, you would have been pushing about 1 G laterally. And 1 G laterally means that you're actually holding your entire body weight with your arms going from side to side. That makes a lot of muscle here and in your shoulder. Okay, pretty impressive. All right, thanks very much. Bell's gonna go soon.